Yeah, I'm connecting to the container, guys. So what I did the created a directory in the EC2 instance, and directly I'm connecting to the that container, guys. Sorry. So I want to connect the container bash. Yeah, now I'm in the container. Go to cd usr share nginx html. Yes, nothing is there because of attaching you are attaching your local directory to the this directory. So now exit, then cd temp nginx html, right? So this is your temp directory vi index.html. Right, guys, before that I will take this. It's not showing, right? Directly we will create it. HTML simple project code or something like. Paste WQ. Guys, first name, last name, username, password, and submit. Guys, understand? It's a simple form, guys. Guys, able to understand what is that mounting, guys? A bound mounting. When I did you watch it the recording? Guys, did you watch it the recordings?
Yeah, Hari, I watched it.
You watched it, huh?
Yeah.
So what is bound mounting? Host mount mounting point.
Post morning, we can take the file
Hmm.
from the host side and
Hmm.
it will share it to it will mount to the in the container
Hmm.
and then we can distribute that one.
Hmm. Very good. Guys, practiced or not? We have it 2 days or 2 days, right? So I have 1 day, right? Guys, Docker is very important, guys. If you want to learn Kubernetes, we need a Docker. Using host file with the two containers. So mounting the bound volumes. What is that, guys? So mounting the bound volumes means so you can create a directory in the EC2 instance. You can attach it to the Docker container. So host directory mounting. What is it, guys? Host directory. Host directory mounting to the Docker container. So this is the concept interview. So how can I mount my host mission directory to the Docker container? Is it called as a bind mounting concept? What is that, guys? Bind mounting. Host directory mounting is nothing but a bound mounting. So bound mounting. Guys, understood? So you created the temp directory, temp nginx HTML directory to the your local directory, and then cd go to the mount directory and create an index file, a VA index file. Now you should write, guys. So this was done. So as of now, what we discussed below. So what is a virtualization? What is a containerization? What is a Docker? Advantages of the Docker. Docker setup, Docker terminology, Docker file, Docker image, Docker hub, Docker container, Docker image commands, Docker container commands. So writing a Docker files, Docker volumes, named volumes, bind mount volumes. So stateless container and stateful container. Guys, so we as of now we discussed these. You guys are good with these concept, right, guys? So real world applications, monolithic architecture application and microservice architecture application. So before containerization, everything will be monolithic architecture. So monolithic architecture means everything will be a part of one project. Monolithic applications are very difficult to maintain. So very difficult to maintain. Microservice, the whole functionality of the application divided into several sub projects which are easily to maintainable. Set of APIs will be available, and every API is a one application, so every API will one container. Example, make my trip is implemented in microservice architecture. So flights is in one API, trains is in one API, buses is in one API. So in the real time, all are using the microservices. Nowadays, all are using the microservices deployment. After the Docker, everything will be microservices. So before Docker, everything will be monolithic application. So monolithic application is nothing but a single application. So monolithic application, architecture application, Docker only one Docker contains every application. Microservice based applications. For example, e-commerce, guys. The products API. So product API is a one container. So products, you are selecting the products, right? Then you are adding to the cart. Cart is a, another API, another microservices. So products API is a one microservice. Cart API is another microservice. Payment API is another microservices. Tracking API is another microservices. So it's a Docker container. This also contains a Docker container, Docker container, Docker. This is a microservices based application. So this is nothing but a monolithic application. So microservice based application, what is that, guys? Make my trip. Make my trip having flights, trains, buses. So flights is one API, trains is one API, buses is one API. This contain in the one Docker, this contain in the one Docker, this contain the, if anything goes wrong on the trains, it will not impact on the bus and flights. But in the monolithic, if trains having an issue, everything will be having an issue. So that is the reason. So nowadays, so every application is designed as a microservices based applications. So microservices based applications. You guys understood monolithic? So what about the difference between monolithic and microservices? Guys understood? Guys speak out here. Guys
Uh,
understood or not?
yeah, yes,
Yes,
understood.
right. So what is the difference between monolithic and microservices, guys?
In monolithic, we will maintain only into the one application in
Hmm.
a single module.
Hmm.
In microservices, it will be coming to the individual modules. Like,
Hmm.
yeah,
Very good. So for example, so so WhatsApp having how many modules? So for example, we are taking three modules. One is chat, one is
yeah,
status, one is contacts.
that,
So these three are the three modules. So in the monolithic, everything will be one one container. Everything will be one container. So but in the microservices, so chat to status starts having one container, status having one container, and contacts having one container. So this is nothing but a microservice application, microservice application. So this is nothing but a monolithic application. All three are in the one container. All three are in the one container is nothing but a monolithic. Guys, understood? So this is nothing but a chat status contacts. So we have a, so this is the WhatsApp. WhatsApp. So this is the WhatsApp. So this is a container. This is a Docker container. So this is a Docker container. So this is also a Docker container. So this is also a Docker container. So this is also a, yeah, this is also a Docker container. So this is a monolithic. So what is that, guys? So this is a monolithic application. This is a monolithic application. So this is a chart as a container, a status as a container, and contacts as a container. So this is a microservice based application. Microservice based application. Guys, understood the difference between monolithic and microservices? Guys, understood now? Yeah, very good. Now you guys understood about the monolithic version versus microservices. Monolithic versus microservices. Monolithic means everything will be one container. So microservices mean so everything will be divided into parts and deployed as a container is nothing but a monolithic microservices. If products having issue, something like this is having issue, so it will not impact on the cart API, payment API, tracking API. That is the big advantage, guys. Yeah. So Docker Compose, guys. So Docker Compose. So Docker SAM, Docker Compose, something like, guys. So container deployed in the EC2 instance. We don't know, guys, how to monitor if the container is stopped, if the container is starting, or if the container is crashed. So how you can identify, guys? How you can identify? So we cannot identify, right? So we need to monitor, or we need to track, or we need to manage the containers. So how we can manage the containers, guys? How we can manage the containers? How we can manage the containers? So having, and our application having, so these three containers. So who will manage these three containers? If it is running, or if it is crashed state, or if it is so if it is in stopped state, so we cannot identify, right? So if you check it, if you go to the server, then if you check it, then only we can find it. But we need a orchestration tool, orchestration management tool, or so management tool or a orchestration tool. So orchestration, so something like a music orchestration. So so orchestrator, you know, right? A music orchestrator. guys. So this is the music orchestration, but music orchestrator, we need a orchestrator. So to manage the music, so he will give you the signals. So which instruments need to play at which time, right? That orchestrator, you see, guys. So he is the music orchestrator. So he is managing this. He is managing this troop, right? This music group or a troop. So who will manage, guys? Music orchestrator. So same like as a container orchestrator. So how we can manage our containers? How we can manage our containers? So Docker Sam. Docker Sam is the, so who created this Docker Docker company created that Swarm. Docker Sam. So Docker Sam is the so container orchestration. So container orchestration tool. So this having some drawbacks, guys. So that's the reason. So that is the reason this is introduced. So this is introduced. What this is, guys? So Kubernetes is the container container orchestration tool. What is that, guys? So container orchestration tool. So Docker Swarm and the Kubernetes are the doc container orchestration tool. Guys, understood? Guys, speak out, guys. Please speak out. Guys, understood? So how we can monitor these containers? So we need a container orchestration tool to monitor manage or monitor this container tool. So Docker itself created their own tool called as a Docker SAM. So Docker SAM having some drawbacks. So that's the reason. So Kubernetes is developed. So Kubernetes is developed. Kubernetes is a container orchestration tool. Who developed, guys? Who created this one? Does anyone knows who created? Initially, it is Google. Initially, it is Google. Guys, understood? Now you understood, guys, why Kubernetes? Yeah, Docker Compose. In the real world, applications are getting developed using microservice architecture. In microservice architecture, several APIs will be available. Every API is a project and it should be run in as a container. So running multiple containers manually for all the APIs is difficult to job. So all the APIs is difficult to job. Note, to solve this problem, Docker Compose comes into the picture. So Docker Compose is a tool which is used to manage multi-container based applications. Using Docker Compose, we can define, deploy multi-container based applications. Multi-container based applications. So Docker Compose, guys. So Docker Compose. So we will give input to the Docker Compose using YAML file to run the multiple containers. What is that, guys? So we'll give a input to the Docker Compose using YAML file to run multiple containers. Docker Compose YAML file should have information related to all the services. So sample Docker Compose YAML. So Docker Compose YAML file, guys. So what it contains? Versions, services, network, and volumes. Simply, so what it contains versions, services, network, and volumes. So Docker Compose file, docker-compose.yaml. So how you can create the compose file, guys? This is Docker Compose YAML file should have information related to all our services. So for example, version is there, services is there, network is there, volume is there. So Docker Compose up, Docker Compose PS, Docker Compose down, Docker Compose images. So Docker Compose hyphen file up and down. So Docker Compose setup. To download the Docker Compose sudo, so you can use this one and give the permissions and how to check Docker Compose is installed or not. So Docker Compose hyphen version. So Docker Compose hyphen version. Guys, you guys can set up and you guys can try it this one. Okay. Yeah, so monthly containers are running. So Docker Compose, MySQL database container, WordPress container. So Java app container, Redis container, MySQL DB container. So these are the Docker Compose file to run the multiple containers in. So multiple containers. So managing multiple containers is difficult, right? Monolithic and microservice based. Something like a cart API, products API, cart API, payment API, tracking API. These all are the containers. So these three containers, products, cart API, payment container will connect to the DB container. And the Docker container, this tracking API container will connect to the Redis container. So managing multiple containers is difficult. So, so that is the reason Docker SAM comes into the picture. Docker SAM comes into the picture and Docker. So Docker Swarm is having some drawbacks. That's the reason Kubernetes comes into the picture. Guys, understood? Yeah, Kubernetes. Guys, understood?
Yes, sir.
Yeah. So Kubernetes, it call it as a K8S. So 1, 2. So here from K to S in between. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 letters are there. That is the reason K8S. Kubernetes short form is K8S. Why it comes? So how it comes? Something like 1, 2, 3, 4, 5, 6, 7, 8 letters. In between K and S, there is a 8 letters. That is the reason K8S or a Kubernetes. So task, app development, create a container and launch app on K8S. Launch app on K8S. So this is the Kubernetes architecture. I will show you guys. No worries. So Kubernetes is easy. What is that, guys? So Kubernetes is easy. So Kubernetes not get started automatically. Single host nature of your Docker container, auto healing. So right. So why Kubernetes not get started automatically? If uh, if a single host nature of your Docker container, something like a Docker is automatically stopped. So it is not started automatically. If stopped or not automatically, auto healing. So there is no auto healing, auto scaling. Kubernetes are automatically started, auto healing, auto scaling, default feature in load balancing. Enterprise Docker is a simple platform. It does not support enterprise level. When we deal with the big applications, so load balancing, firewall, auto scale, and healing API gateways. Who is solving these problems? So these many problems are there. So not get started automatically. Auto there is no auto healing or there is no auto scaling. It is not an enterprise level. No load balancing. No firewall. No auto scaling. No healing. No API gateways. Who is solving these problems? Kubernetes. So Kubernetes solve all the problems. Who is solving these problems? Kubernetes. In general, it's a master node architecture. So cluster is nothing but group of nodes, master nodes and worker nodes. So faulty node immediately will create a new nodes or pods. Replication controller. So replication control is nothing but a replica set. The container increasing the traffic. Replications at YAML file, replication controller file increases. Heal Kubernetes control fix the damages. So what is the meaning of auto healing? Container goes down. So as a feature called as a auto healing, it goes down. It is automatically start a new container. So rolling out a new container, Kubernetes roll out a new pod or a container going down. So Kubernetes are Google. It's created by the Google Borg language. A Borg, it is not an open source tool. Even a better solution, the enterprise level orchestration platform. Guys, understood? So Kubernetes is an orchestration engine. What is that, guys? Kubernetes is an orchestration engine. Kubernetes is an open source software. Kubernetes is used to manage containers for our applications. Kubernetes will take care of the container deployment, scaling, descaling, and container load balancing. K8 is not a replacement for the Docker. K8 is a replacement for the Docker SAM. What is that, guys? Kubernetes is not replacement for the Docker. Kubernetes is replacement for the Docker SAM. I already told you, right, guys? Docker SAM. So K8 is developed by the Google and donated to CNCF in 2014. So what is CNCF, guys? So guys, what is CNCF? Yeah, what is this, guys? Certified Kubernetes Administrator. I am a certified Kubernetes administrator. I wrote the exam for the CKA. Guys, understood? Now you understood, right? The Kubernetes. What is Kubernetes? Guys, what is Kubernetes? Kubernetes is a
orchestration tool.
yes. Kubernetes is a orchestration tool. So it will manage the. So what it will manage, guys?
Cascading management application
It will manage the containers.
containers.
It will manage the
Container.
containers. So Docker SAM before. So which so what is the Docker orchestration they are using? Docker SAM is the orchestration tool. Same Docker SAM and that Kubernetes both are working same, but the so Kubernetes is popular. So the same way, Chef, Puppet, Ansible, both are the configuration management tool. So why Ansible is popular? Because of agentless. This is also Kubernetes also having some features rather than the Kubernetes. Guys, understood? Kubernetes. Now you understood, right, guys? Kubernetes. So Kubernetes is an orchestration engine. It is an open source software. It is used to manage the container of our application. So it will take care of the container deployment. It will take care of the container deployment, scaling, descaling, and container load balancing. So K8 is not a replacement for the Docker. K8 is replacement for the Kubernetes is replacement for the Docker SAM. So K8 is developed by the Google and donated to CNCF in 2014. So what is CNCF, guys? So who will provide this CK administrator exam? CNCF. What is that, guys? So Cloud Native Computing Foundation. So this is the organization. So they are conducting the. So Google is donated to this. So who donated? So what donated to the Google, guys? So that Kubernetes is initially created by the Google, but it is donated to the CNCF, Cloud Native and Computing Foundation. So computing a foundation. So these are the Kubernetes training overview, certifications. So cloud native certifications. The certified Kubernetes administrator. I am a certified Kubernetes administrator Kubernetes application developer also. Certified Kubernetes security specialist. So Kubernetes and cloud native associative, Kubernetes and cloud security associative, Prometheus is Prometheus certified associative, Cisco certified, Calcium certified Argo project. So Argo CD, guys. So the certified Argo project associate is an associative level certificate designed for the Argo CD also. Argo CD Kubernetes. I am a certified Kubernetes administrator. I did the certification, guys. The cost. So what is the cost, guys? Guys, how much the cost for the CK exam? Guys, speak out, guys. Are able to see? Exam fees enta? 395.
32,000, bro.
395 into So 78,
80 rupees.
now 80,
82.
82,
83.12.
395 into, for example, 80,
83.2.
no worries, 32,795. So if you want to write a CK exam, you need to pay 32,785, guys. Okay. AWS solution associated కదా. So they are giving 40% limited offer, guys. But I did at the time 13,000 or 14,000. Limited time offer, grab it now. 6 days, 6 hours. 40% of limited time offer. Our amazing fact and features. So 40% off. So you guys are getting 40% off, guys. So 14,000 I paid. So for 35,000 for CKA, 30,000 for RHCSA and RHCE. 35,000, 30,000 and 18,000 for ITIL. What is that? 13, right? 14,000. 14,000 for AWS solution architect. So this is the amount I paid, guys. So no one, something like some companies are providing the vouchers, guys. So I worked on minimum 5-6 companies. So I never get chance. I remember reimbursement, guys. So what is that, guys? 33,000 plus 30,000 plus 18,000 plus 14,000, guys. So I did the certifications, and I paid 95,000, guys. Guys, you can also once you get the job, you guys also try to or done any certification. So we'll do any certification in every hour, every year. Every year you can try to do any certifications, guys. Okay. So if company provides, so you guys can, it will be good for you guys. It will be good for you to reimburse, right? So you guys can try to do any certifications every year, guys. So finally you will get a good knowledge. Okay, guys, understood? So who is maintaining the Kubernetes, guys? Guys, who is maintaining Kubernetes?
Cloud native founder.
C and CF. You guys are cloud native. So compute a foundation. Cloud native compute foundation. So CNCF means cloud native computing foundation. So Kubernetes software is developed by using the Go language. Which language, guys? So Go language. So K8 is version 1.0 released to the market in the year of 2015. So what is the version now, guys? Kubernetes version So 1.27, 1.29. Yeah. So what is the guys? So release end of the life. So what is the release guys? 1.30. So 1.30. How many releases comes? So 1.0, 1.1, 1.2, 1.3, 1.30 released to the market in the year of 2015. So Docker SAM versus Kubernetes. Docker SAM versus Kubernetes. Both are doing the same. So but they have some drawbacks, some advantages. So Docker SAM no auto scaling, but Kubernetes auto scaling. Why guys? What is auto scaling? Guys, so what is auto scaling? Auto scaling is nothing but a scale down and a scale up. It automatically, if the if the traffic is increases, it automatically so scale up the pods or containers. So good community. It's a great active community. Easy to start a cluster, difficult to start the cluster. So limited to the Docker API's capabilities, can overcome contain constraints of the Docker and Docker API. So does not have a much experience with the production deployment at a scale. So deployed at scale more often among organizations. So K8s features. So official website is kubernetes.io. So what is the official website for the Terraform guys? Guys, so what is the official website for the Terraform and what is the official website for the Ansible?
Terraform registry.terraform.io.
So registry.terraform.io, not terraform.registry. Registry.terraform.io is the Terraform
No,
official website. So what is the Docker guys? Ansible docs.ansible.com. And what is the website? What is the hub Docker hub URL guys? Docker registry URL, Docker hub URL. hub.docker.com. The same like as a K8s official website, https kubernetes.io. Guys, చదవట్లేదు మీరు. So kubernetes.io. So the Kubernetes features automated scheduling, self-healing capabilities, automated rollouts and rollbacks, load balancing, service discovery, and storage orchestra. Storage orchestra. These are the key features. Automated scheduling, self-healing capabilities. What is self-healing means? So if any pod crashes, it automatically started a new pod. So automated rollouts and rollbacks. If you want to roll back, it automatically roll back. A load balancing. So what is load balancing? Say that sharing the traffic, service discovery, and storage orchestra. So K8s features. K8s Kubernetes providing advanced scheduler concept to launch containers depends on our requirement. So what is that guys? Depends on our requirement. Restarts container that fail, replaces, reschedules containers when nodes die, kills containers that does not respond to your user defined health check, does not advertise them to client until if they are ready to serve. So if something goes wrong, Kubernetes will roll back the change for you. Take advantage of a growing ecosystem of deployment solutions. Scale your application up and down with a simple command. So with UI or automatically based on CPU usage. So note in Docker Swarm, load balancing is manual process where K8s supports the auto scaling. So Kubernetes architecture. So what is the architecture? Kubernetes works on a cluster model. So what is a cluster guys? Group of nodes, group of node. A node is nothing but a EC2 instance. Group of nodes is nothing but a cluster. So group of nodes. So Kubernetes cluster will have master nodes and worker nodes. So guys, Kubernetes cluster will have a master node and worker node. So master node is nothing but a master EC2 instance, and node is nothing but a EC2 instance. Master node and worker node. So master node and worker node. So what are the components are there in the worker node? API server, controller manager, etcd, pods, so containers, so Docker runtime, kubelet, kubeproxy, kubectl. So guys, everyone can speak out these names. What is that, guys? Master node,
Work node,
yeah, worker node,
Node,
worker node, API
mm,
server,
API
API
server, controller
controller
control,
manager,
manager,
mm,
DCD,
TD,
etcd,
pods,
pods,
containers,
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 Docker runtime,
Docker
kubelet,
runtime,
kubeproxy,
kubelet,
kubectl.
kubepro.
kubelet, kubeproxy, kubectl. So the kubectl, kubeproxy,
So,
kubelet, a Docker runtime, containers, pods. Guys, you know containers. You don't know pods, right, guys? So we'll tell you, no worries. A logical unit, the pod is nothing but a logical unit, and pods contains the containers only. So master node, worker node. In Kubernetes cluster, we will have a master node and a worker node. So we'll have a master node and a worker node. Guys, this is the most important topic, guys. Docker and Kubernetes. You guys practice thoroughly. Otherwise, you cannot understand. Right, guys? So what is a cluster? What this is, guys? A cluster. So what this is, guys? A cluster. Cluster. Cluster contains, it contains the group of nodes. What it, guys? Group of nodes. What it is, guys? What this is, guys? So this is a EC2. So this is also EC2 instance, guys. EC2 instance. EC2 instance. So this is a EC2 instance. What this is, guys? So this is a master node. A node is nothing but a instance. Guys, a node is nothing but a instance. Master node, and this is a worker node 1. This is worker node 2. So in the worker node, what we having? So these are the pods, guys. What these are? These are the pods. Contains a pods. Pods contains a container, guys. Pods. Pods contains a container. For example, this is a container, guys. So pods contains a container. Guys, understood? Container. So container. Yeah. So master node is master node is managing the master node is managing the worker nodes. Master node is managing the worker nodes. So what are there in the master node? API server, HCD, controller. So API server, HCD, controller. What is that, guys? So API server and a controller, a scheduler, guys. So what is that? Scheduler. Scheduler. What are the components are there in the master node? Guys, everyone can speak out. So this is a master node, or it call it as a control plane. So it call it as a control plane. So control plane. So this call it as a data plane. So data plane. So this is also a data plane. Yeah. So so what it is, guys? So this is a Kubernetes cluster. So funny, what are you doing? Funny. So who is writing? Yeah. So master, this is the control plane. This is the data plane. So this is the Kubernetes cluster. What it, guys? It is a Kubernetes cluster. K8s cluster. Kubernetes cluster. In the Kubernetes cluster, a cluster is nothing but a group of nodes. Every node is nothing but a instance. So we have a control plane and a data plane. Worker master node and worker nodes, guys. Master node and a worker node. Guys, now you understood the diagram of the Kubernetes? Just a layman diagram, guys. This is a layman diagram. Layman diagram for your understanding. For your understanding, guys. So I will show you the diagram of the architecture of the Kubernetes. But guys, you are able to understand or not, guys? Guys, are able to understand or not?
బ్రో అంటే ఈ క్లస్టర్ లో మేజర్ గా ఒక మాస్టర్ నోడ్ ఉంటుంది. దాని నుంచి మిగతా డేటా ప్లేన్స్ అనేది ఇన్స్ట్రక్షన్స్ వెళ్ళి వాటి నుంచి తర్వాత
పాస్ చేస్తుంది. సో ఎలా అంటే, సో మనకేంటి డోకర్, సో ఫైనల్ ఏంటి కంటైనర్స్ ఆటో హీలింగ్ అని, ఆటో స్కేలింగ్ అని, లోడ్ బ్యాలెన్సింగ్ కానీ, నెట్వర్కింగ్ కానీ, ఎవ్రీథింగ్. సో దాని అందరికి అది చేసుకోలేదు కాబట్టి, సో ఏం కావాలి మనకి? మేనేజ్ చేసే ఒక మేనేజర్ కావాలి. హూ ఇస్ ద మేనేజర్? Kubernetes is the master node is the manager to control all the worker nodes, containers. Okay, guys, understood? Speak out, guys. Speak out. Yeah, now you understood, right? Master node, worker node, API server, control manager, HCD, and scheduler, pods, containers, Docker runtime, kubelet, kubeproxy, kubectl. So this is parts. What this is are the worker node, guys. I will show you. So what is a scheduler? So what is a scheduler? It will schedule spots. It will schedule spots for the execution which are. So we'll tell you tomorrow, guys, because if you start, so we need to tell everything, right? So this is the diagram of the architecture diagram of the Kubernetes, guys. This is a UI interface. This is a kubectl. So how you can connect with the Kubernetes by using kubectl or by using the rancher. So rancher or a lens. You can use a lens for the UI. Right, guys? Control plane. So control plane is nothing but a worker node. Worker node contains the API server, scheduler, control manager, and etcd. And the worker node 1, worker node 2. So these are the worker node. So worker node contains the pods. So within the pods contains the containers. This is the Docker runtime, Docker service. So if you want to run the container, right? So we need to run the container. Kubelet and kubeproxy. Kubeproxy is for the networking purpose. Kubelet, so it will give the instructions. It will give the instructions. Took the instructions from the master node, and it will verify if the pods are running or not. If the any pod is crashing, we'll check the kubelet, guys. Kubelet. Guys, understood? This is the architecture diagram of the Kubernetes. This is the architecture diagram of the Kubernetes. Guys, now you understood the terminology: master node, worker node, API server, controller, etcd, scheduler, pods, container, runtime, kubelet, kubeproxy, kubectl. Now you got it right, guys? Yeah. So
Yes.
API. So in the control plane master node, we have a API server, scheduler, controller, manager, etcd, and worker node having the pod, container, Docker runtime, kubelet, kubeproxy. So if you want to connect the master node, you can use the kubectl is the command. What is the CLI command? You can use the CLI command kubectl. So UI you can use the rancher or you can use the lens. You can use the rancher or you can use the lens to connect the UI. So kubectl is the for the CLI. So for connecting the AWS, so one is a console, UI is the console, and AWS CLI is the AWS CLI to connect the AWS. Right? The same way, this is also we have a two types. One is UI and another one is a CLI. CLI. Guys, got it? Why Kubernetes? How Kubernetes? Guys, got it or not?
Got it.
Yeah. సో వినయ్ వెళ్ళిపోయారా?
లేదు చెప్పండి.
ఐడియా ఉంది, అర్థమైంది కదా?
యా, understood.
1 second, guys.